Hi, everyone. Welcome to the Digital Supply Chain Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Paul. Paul, welcome to the podcast. In fact, welcome back to the podcast, not your first time. So thank you for that. For people who are unaware, would you like to introduce yourself?
Sure. My name is Paul Walsh. I'm currently CEO of a company called Meteomatics North America, which is a division of a company that's been around for about 12 years based in Switzerland called Meteomatics. And I recently joined, I guess, back in April to basically lead the development of the business here in the US.
Okay. And what does Meteomatics do, Paul?
Well, we're providers of very, very high quality weather and climate data, first of all. So we've developed a platform that includes weather data from around the world. So historical weather data, forecasted weather data, seasonal forecast data. So looking out, beyond several months, actually out to about a year, as well as climate scale forecasts. So the platform itself is really developed for large companies that have data science teams that are looking to create innovation around data. So digital innovation, I guess would be a better way to describe it. So measuring the impact that weather has on consumers, for example, measure the impact that the weather has on crop yields, et cetera, et cetera. More and more companies are looking to basically leverage the existing data sets that are distributed around the world. But one of the problems of the data that's distributed around the world is that it's distributed around the world, and there's various formats to get the data. There's various difficulties in getting the data. There's various pricing around that data. So more and more large companies are looking for single entities to partner with where they can get everything in one place. And so that basically is the platform of Meteomatics. Of course, the company's been around for about 12 years or so it's very well established in Western Europe, working with companies such as Airbus, Shell. We actually work with Tesla, as well as with a company called Tesla Energy, which is not to be confused with Elon Musk's business, but I would say about 450 customers in Europe, and we're bringing it now to the US. A couple of other highlights. One of the really important things is that Meteomatics has developed what we call a 1 kilometer forecast, which is now live in Western Europe. And what that means is that we're calculating a weather forecast every hour at a resolution of 1 kilometer. And what that means is that every hour we're bringing in all of the real-time weather data, so weather radar data, satellite data, weather observations, as well as the predictive models when they come out, in the sort of the parlance of weather geeks like the ECMWF or the GFS models that come in every 6 hours or so. We bring those in, but then what we do is we actually recalculate on an hourly basis the prediction of the weather for the next 48 hours in Europe. Again, this is live in Western Europe. It's the most granular, and I would fight anybody who argue with me, the most accurate weather forecast that's available today. And really, the intent of that forecast model is to be sort of the next generation of weather forecast data, which is going to be needed as we move into the area of, for example, drone operations or autonomous vehicle operations, where you need to have as hyper-local and as accurate weather data as possible. And then finally, what I think is the coolest part of what we're doing is we've developed something called a Meteo drone. And a Meteo drone does effectively the same things that a weather balloon does, or as we call it in the industry, Ravensun balloons. The Meteo drone literally flies straight up from what we call a media base, which is effectively where the drone takes off and lands itself. It's autonomous. There is a pilot, but the pilot is basically flipping a switch. The Meteo drone goes up. And in Switzerland, we've got 4 Meteo drones operating every night across the country of Switzerland. The drones go up today about 6 kilometers, come right back down. It takes about 30 minutes. Super cool. But more importantly is the data that's collected then is instantaneously pulled back into that 1 kilometer model. And so the model gets increasingly more accurate as you can bring in more and more of this low level data, which is obviously where we all live in the lower parts of the atmosphere. So the goal, Tom, is to bring this 1 kilometer model, as well as increasingly add to our fleet of Meteo drones across North America, and then, of course, in the future, across the rest of the world. Because of the fact that this level of data then enables large companies to bring it into their system, do analytics around that data to understand how the weather forecast is going to shape consumer behavior, consumer demand, whether it's in the energy world or in the supply chain world, or it's in the transportation world, any of those verticals that are impacted by weather, to be able to optimize the way that they operate. And the way to optimize the way that these businesses operate is not just having raw weather data, but it's having highly accurate, highly localized weather data that can be analyzed and using standard sort of analytical tools to understand what is the effect or what is the impact of that weather historically. And then you turn that lens forward and you use that as a predictor in terms of how you should better prepare for the kind of weather that's going to be happening. And then thirdly, integrate those insights, those analytical insights that are based on the sort of hyperlocal, historical, and forecast data into operational systems like SAP, for example, or other types of systems like that, which is really what makes the insight more valuable, because then the insight is driving action at scale. So to wind this all the way back, Tom, it all sits on this sort of foundation, this platform of data that then can be accessed and integrated by large enterprises. And so that's where we're headed now, and I'm super excited about it. Of course, I've been in the weather world for, as you can tell by my gray hair, for a very, very long time, and I see this as sort of a way for us to really, in real time, continually improve our ability to be more responsive to the kind of really, really unusual and not unexpected weather conditions that we're experiencing as we speak here across the U.S. The weather conditions have just been unbelievably hot in parts of the country. Of course, we've got the wildfires in Canada which are blowing smoke down, which are causing all kinds of health problems. We're living and seeing the impacts of climate change now. But on the optimistic side, and I know you're in the same camp as me, I think there's a lot of technologies out there, and there's a lot of efforts that are happening right now that are going to help us better deal with this. And in our world, that starts with having the best data possible and having it positioned or leveraged in a way that makes it very easy to use. And of course, then also, we're doing a lot around evangelizing the use of the data, like the conversation we're having right now, so that more and more people understand that it's one thing to have data, but the data doesn't have value unless you can understand the effect that weather data has on your customers or your business, number one, and number two, how you can then take that the next step, which is the most important step, and integrating that into processes and to technologies to be able to take advantage of having those insights. And
Sure.
I'll stop talking now because I feel like I've been pontificating. Maybe I had too much coffee today.
No, it's fine. It's fine. I'm just curious, Paul, the 1 kilometer model that you referred to, do you think that branding will work in the US? I mean, are people in the US familiar with the concept of a kilometer versus a mile, for example?
Wow, that's a great point. And Tom, we have actually introduced the 1 kilometer forecast model in the U.S. in the state of North Dakota. So that's our first instance of it, as well as the media base and a media drone. So that's where it's starting in the U.S. I don't know. I think 1 kilometer is a cool brand. It's easy to say, and I typically, when I explain to people in the U.S., I say it's a little bit over half a square mile,
Right.
plus or minus. So they get it. But it is a great point. We don't do temperatures in centigrade here or distances in kilometers, but it is translatable, and it is like I said before, it is operational in North Dakota, and the goal over the next year or two is to bring the whole process here. The one thing I'll say though about it is that you can imagine, if you think about Western Europe and a 1 kilometer resolution, or for my American friends, a half a kilometer or a half a mile, plus or minus. There's an incredible amount of data that has to be processed. And what we found is that the most efficient and effective way to do that is not to do it in the cloud, but actually to do it on high performance computers. So we basically run this data on high performance computers now in Europe, and that's the way that's the most efficient and effective way to really be able to process that amount of data, because it's absolutely massive. But
Fascinating.
again, from an optimistic side, it's the year 2023. We may not have been able to do this in the year 2013, and in the year 2033, you can only imagine the kind of the power of the computers that will be driving this, and also the overlay on top of that of AI,
Mm.
wherever that's going to land, because the AI piece of this is not necessarily in the physics in terms of creating the forecast model, where the AI piece lays in or overlays on all of this is in the decision making that needs to be made, and being able to scale and learn from decisions that need to be made on the back of an insight that comes out of the data that's crunched from this foundationally improved weather data.
Yeah, and we saw a couple of papers emerge in the last few weeks around superconductivity, room temperature superconductivity, which could have massive implications for quantum computers, which of course could have massive implications for weather forecasting, to your point about 2033. So it'll be
Right.
fascinating to see what does happen in the next years in terms of weather forecasting. But this is the Digital Supply Chain podcast. So talk to
Yep.
me a little bit, Paul, about, before we get onto the drones, because we're going to come to them, because that's fascinating as well. But talk to me a little bit before that about how supply chain organizations could use this data. A, how they could access the data, and B, what would they then likely use it for?
There's many applications from a weather perspective and within supply chain. Obviously, accessing the data, that call me and we'll connect you to our platform and you can access the data. But to give you some examples of companies that I've worked with in the past, one large CPG company was interested in understanding and optimizing around packaging of their products, and their products were like chocolates and cookies and things like that. They sell all over the world. They wanted to make sure that they were, on the one hand, they could create a package that was very light and effective in sort of like tropical environments, but also was much lighter and much more efficient than what they're currently using. Effectively, to help them sort of lower the weight of the products that they were selling or
Sure.
transporting, I should say. And then also they wanted to have a better understanding of when they would be able to get away with using non-refrigerated trucks versus refrigerated trucks. They were by default using refrigerated trucks everywhere because these are relatively hot regions, but they didn't have the data or the wherewithal to understand if they were going to need air condition the refrigerated trucks at time, like in the middle of the night at certain times of the year. And even having the data, having this sort of hyper local data, and most of this work was based off of historical data, it gave them the insights that they needed to make decisions around when they would basically go with a non-refrigerated truck. Maybe it's in the middle of the night at a time of the year where the odds of it being so hot that it would extend, or that it would be damaging for the products that they were using, the new packaging that they had developed using this exact same weather data. Also, in terms of, I'm not sure if this is exactly a supply chain issue, but I think it is, but from a demand forecasting perspective. So large grocery chains having a better understanding of how much inventory they would need for seasonal product categories. Seasonal product categories probably make up more than 50% of what grocery chains are selling. I've personally worked with customers in Europe that were using weather data in exactly the same way, basically correlating the impact of weather and weather forecasts, because that's becoming increasingly important, on demand for certain items, and then using the insights that they garnered from those analytics and the ability to integrate it into their demand forecasting systems and into their supply chain system, to be able to basically be responsive to expected changes in the weather that were going to have a meaningful impact on demand, so that they could either make sure they had enough product on the shelves for customers,
Mhm.
or they made sure they didn't have too many products. So for an example, I'm talking to you today from Bethany Beach, Delaware, and last week it was incredibly hot. It was, I think the heat index here at my cottage was well north of 105. That heat wave had been predicted 7 to 10 days in advance. So it's one thing to know it's going to be hot, but it's a whole nother thing to know that, okay, when this happens in Delaware, we typically sell, like a home improvement store might know from analytics that they sell 3 times additional room air conditioners. And having enough lead time to be able to, in advance of that event, make sure that you've got the inventory that's going to meet that demand is hugely important. It's hugely important now because of the variations that we're seeing. I mean, today it's just barely 80 degrees. It's relatively cool. I've got a little weather station here right in front of me because I am a geek. But having that sort of information is very, very important as it relates to, number one, meeting customers' demand, but number two, also ensuring that you are maximizing profit margins by either being able to sell all the products that the demand is there, or the avoiding with the worst case situation, which is somebody shows up when it's 105-degree heat index and you've sold out of every single air conditioner, or there's no bottled water left, or any of this other types of products that are going to be increasingly in demand as we are seeing these huge swings in temperature and these record-breaking heat waves. And so that is the kind of thing that sort of I've been focusing on really for the last 20 years. But also there's transportation issues. There was an issue in Italy just last week where an aircraft ran into, you might have saw this in the news, ran into very, very large hail, and the entire front of the plane was bashed in, basically. Fortunately, they were able to turn around and land, but as it turned out, when we went back and looked at our data, that hailstorm was actually very, very visible on the models that we've developed. So that kind of information in the hands of aviators, in the hands of large fleets of aircraft that are flying products from point A to point B, can increasingly assist in terms of the ability to avoid those incidents. And also better forecasts at airports, for example, will ensure that you're able to fly more rather than less by having more precise information in terms of when the fog is going to lift, or is there icing above us that's going to impact the flight, or is there not? The more you know, the better you're able to sort of increase flight times and reduce the cost of sitting on the runway burning gas. And so, and back to another example I was giving you around the packaging and having a better understanding of if you can get away with using a refrigerated or a non-refrigerated truck. All of those things help in terms of reducing the carbon footprint, because a refrigerated truck uses more gas, burns more carbon. And so those are the kind of things, and I could go on probably for hours and hours talking about this, but it's an example of how if you can measure something, you can manage it. And when you go back to from an analytics perspective, and you've got the kind of data that we have in our platform, where you can actually go through and at a very hyper local level measure historically what the effect of the business or of the weather was on whatever business that you happen to be looking at, you can then better manage the way that you react and respond and plan for events that are increasingly impactful.
Okay. And what about things like, I mean, we've seen multiple instances this summer of flash floods here in Spain, in Zaragoza, in Beijing, in places like that, where we've had hundreds of millimeters fall in 10, 15, 20 minutes. Are things like that predictable ahead of time?
They are, and increasingly we're getting better at being able to predict those kind of events. I think there's a lot of interesting technology that's happening now in terms of being able to better understand where flash floods are going to happen and be able to sort of warn on that. Prior to joining Meteomatics, I was with Google for a time, and that's one of the things that Google is looking at in terms of being able to predict the onset of flash floods globally, like around the world. And then, of course, the next thing is, and we'll see this over time, is providing more and more people with the means to actually get that information. Because it's one thing to know, but if it's not communicated, it's kind of like the bear in the woods, if you know what I mean. And so it's really, that's another thing that I think is exciting about what the future holds in terms of our ability to get internet access around the world. More and more people will be using mobile phones, even people in areas where there's limited literacy, but phones actually can help sort of communicate those kind of things. And those are the kind of ways that technology, I think, is really sort of coming together to help us deal with not necessarily solving the climate problem, but helping us deal with the impacts that we're seeing today and the impacts that we're seeing more frequently, all related back to obviously to climate change and all the calamitous things that we've been watching happen this summer in the U.S., in Canada, and as you noted, around the world.
Okay, and I assume that your platform then is for customers accessed via the likes of an API, and the data is given in kind of machine readable format. Would that be a fair assumption?
That's exactly right. That's exactly right. The point of of our data platform is to enable very easy access through a single API endpoint that a user, and the user might be a data scientist at a large CPG firm, for example, or healthcare firm, and it enables them to very, very quickly pull the data that they need, run experiments that get the data, run proof of value against innovations that they create, and then scale it and integrate it across the enterprise. So the point of the platform is really to make it easy for larger companies that have data science teams or consulting firms that are working with larger companies to be able to relatively quickly and cost effectively run the experiments that need to be run to create the innovation that leads to the scalable output, which then downstream basically helps to reduce the negative impact of these sort of swinging variables, swinging weather variables, or the extremes that we've been seeing and are continuing to see.
Okay, and now it's time for the drones. So talk to me a little bit about these drones that you developed. You said that they're part of your 1 kilometer model. So how many of those drones would you need in North America to get a 1 kilometer model for the entire North America? Well, for the entire of the United States, let's say.
Yeah, so the 1 kilometer model doesn't require the drones to run. So the drone data is an input into that model. We currently, and it's very early days. We have exactly 1 drone operational in the U.S. today. The goal is to have many, many of them. I don't have an exact number, but it would probably be need to have 50 to 100 across the U.S. My vision is to have, for example, at every location where the National Weather Service here in the U.S. has a rainwind sound operation, that they also have a media drone set up as well as military bases. Because the drones are more efficient and more effective. Weather balloons, of course, use helium. There's been problems getting helium. Also, the weather balloon, you launch a weather balloon and it goes up, and at some point it pops or it gets shot down by an F-15 over Canada, and then it's gone. So it's not very economical to use them, and unless somebody happens to find it, mail it back to the National Weather Service, it's lost. Whereas with a drone, it's completely powered by battery. It goes up and it comes down, and it can be literally run every single hour. But it's going to take time, Tom, to get those deployed across the U.S. because of there's FAA regulations. But it's going to happen. It's absolutely going to happen. And I would say that within the next 5 or 10 years, the fleet of media drones across the U.S. and of course our objective is to get these around the world. And we are talking to countries around the world. And of course we're currently working with the U.S. military, and U.S. Special Operations Command is using some of our drones as well. And so this is more of a longer term vision in terms of getting the drone data, the drones deployed across, and I'm sort of in charge of North America, so that's my first target.
Right.
But really, I think it's going to transform the way collectively we measure the lower, let's say, 20,000 feet of the atmosphere. And imagine if you're able to fly these up every hour, which you can. That data input into a model like the 1 kilometer model is going to contribute directly to the increased accuracy and granularity of these forecasts, which is what you need to get better at all those other things that we just talked about. Because again, the weather data alone, of course, it's super valuable, but where it really becomes a game changer for us as a society is when it is analyzed so you can understand the effect of the impact it's going to have on either an individual or large organs or large industries, and then be able to integrate that data so the data is constantly flowing into systems like, I keep using SAP, but it's just an example that's on the top of my mind, and it's
Sure.
a company that I didn't work with, but we worked together with to do these sort of integrations years ago, actually, in Europe. And so that to me is a great example of how this kind of data basically can drive really valuable outcomes that will help us all become more resilient at the end of the day. Because if something is happening from a weather perspective and you need something, you want it to be there. And maybe it's having a drone fly it to you and parachute it down in your backyard. In order to do that, you need to have really, really good weather data because drones fly at 300 or 400 feet, whatever that is in meters, 100 meters.
Sure. So these drones go straight up. They stay up for a while. I don't know. They go up 6 kilometers. How long do they stay? Well, how long do they stay up? Number one. And when they're up there, what data are they capturing? So, for example, you mentioned the Canadian wildfires earlier. Is that something they could also detect, the outbreak of wildfires, or are they just strictly looking at things like temperature, humidity, air pressure, those kind of things? You know, how long do they go up for, and what do they do when they're up there?
The drones that we're flying operationally in Switzerland fly up to 6 kilometers. It takes about 20 minutes for the entire journey. They go really fast. So they go straight up and it comes straight down. So they don't linger, they just go straight up and straight down. They're
Okay.
measuring the same things that are measured from a weather balloon: temperature, humidity, wind speed, wind direction, and there's other measurements, but those are the basic key measurements that are needed to create what we call stability indexes. And it's the raw data then that gets fed into the model that we described. One thing that I think is super cool about these is that they're engineered to go straight up. And by that I mean, obviously, when you get up to 4 or 5 kilometers, it's super windy up there, and it's going to
Yeah.
want to blow. And the drones are not that big; they're probably a foot and a half across. So what they do is they're engineered to compensate for the wind, and by compensating for the wind, so they can go straight out. That's how it calculates the speed of the wind and the direction of the wind based on the magic that it has to do to
Wow.
make sure that it maintains its sort of straight up and straight downedness. I just made up a whole word my tongue. And then this is where the super weather geeky, not just the geeky part of it. It lands itself in the media base, and then the media base closes up around it. And so that's how we in Switzerland are flying, 4 of those every night with one drone operator that's sitting in front of a computer, maybe in his jammies because it's autonomous, and they make sure that they're cleared for air traffic. And then I'm sure my friends are going to probably give me a hard time for oversimplifying this, but they push a button, it goes straight up, it goes straight down. The data that gets fed back in the model, and so the weather model in the Euro 1K we call it is sort of populated by that data. But where the data would be most effective now, as we speak, would be in our Swiss 1K because Switzerland's not that big, and we've got 4 of them flying up every night. And also, the founder, Martin Fengler, is a mathematician, Swiss guy, a private pilot. The idea for this 1K model came up when he was sitting on the runway trying to take off, and he was being told he couldn't take off because of fog, and he's looking around and said, "There's no fog here." And so he basically, I'm sure I'm butchering this a bit, and Martin will correct me if I don't get it exactly right, but his thinking was, we should be able to do a better job of being able to predict these kind of things. And if we had a better handle on the lower part of the atmosphere, that could help us. And that sort of triggered the whole idea of doing a drone, of developing what we call our media drone. And that was sort of the impetus of it. And I don't know, this probably goes back 4 or 5 years, and they basically just built it.
Okay.
And to this day, we're continuing to build them in-house in Switzerland. And the business has grown really, really quickly. And we have quite a few customers that are using it, and more are using it, including some folks from NOAA and some universities here in the US. And the plan is, as I told you before, to sort of roll that out over the next couple of years.
Okay. And you're selling access to the data on the platform. Will you also be selling drones? So if I wanted to have my own Mediasat drone in my front garden for my own weather station, could I roll up to you guys and say, "I'd like one of your drones, please"?
You can. They're a little expensive, so you probably wouldn't want to, as an individual, do that. But yes, you can. I mean, that's basically the way that we're going to be experimenting with the business model going forward in terms of how we go to market at scale. But right now, companies basically are buying them individually, but they generally are fairly large companies and/or governments. I should say governments first, and then companies second that are developing these or that are actually buying these. But we're going to be experimenting what the business model looks like going forward when we start looking at dozens or even hundreds of these drones going forward. But it's coming. It's absolutely coming. There's imagine that in 2023 we've still got weather people here, I can't speak for Europe, but here in the US, that are every 12 hours they're blowing up a balloon and taking it out and letting it go, and then running back in to capture the data. And then the
Wow.
balloon is never seen again. The balloon goes up to 50,000 feet, it pops and comes down in a parachute somewhere in the middle of nowhere, and no one never sees it again. So that's the way it's been done forever and ever. And it uses helium, so it's not really sustainable. And the
Sustainable that
drone
it's
basically will
throwaway
help
either.
sort of evaluate. What's that?
I said it's not sustainable that it's throwaway either.
Correct. I say it's going to take some years because there's all sorts of like FAA regulations here in the U.S. We've solved some of that in Europe and in Switzerland specifically, but there's a lot of complications. Obviously, if you're flying in a jetliner, you don't want to run into a drone. And so there's things that need to be figured out, but we will, and we have in some areas. And again, in North Dakota, we're able to fly up. I want to say up to 5 kilometers now, but we've got special permission because it's at a military base, and so we've got the ability to do it there. But that's sort of the first instance here in the U.S., and we'll be rolling it out, as I mentioned before, across the country.
I normally at this kind of point in the podcast ask what's next, what's coming down the line for the next 3 or 4 years, but I kind of feel we've covered that off.
Yeah,
unless there's something I've missed, or unless there's something you've missed. Is there anything coming down the line that we haven't mentioned so far?
No, I think I ran away with this and just sort of again, I'm over caffeinated this morning, but I think the big takeaway is the fact that we are currently experiencing the ill effects of climate change. And it's manifesting itself in these, at least this summer, in these tremendous heat waves, wildfires that we're seeing, and coming back over here to the U.S., which is having health impacts, it's having business impacts. So we're seeing everything happening right now. Also, there's this technological change where more and more of our lives are going to be served by drones in one form or fashion, whether it's the local supermarket delivering something to you via drone, or a drugstore chain coming in and dropping off your medicine in your backyard, or autonomous vehicles that are driving all around the country here in the U.S. We're already doing that, which are going to require the most accurate and hyperlocal data possible to avoid issues where there's no human on board. And of course, there's just the whole need to be more resilient and more proactive in terms of how we deal with these kind of events that we've been seeing here. Not to be too U.S. centric, but here in the U.S. And so the innovations that we're seeing, the technological innovations we're seeing, the science that's being developed even in the private sector to help us better deal with this, I think is a very, well, let me just put it, I'm very optimistic that there's going to be a lot of new, not necessarily new industries, but new ways that industries are operating using a lot of this environmental data to help them be more efficient, effective, and help us as individuals be more resilient.
Cool. We're coming towards the end of the podcast now. So is there any question I haven't asked that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to think about?
No, I think I've pontificated probably more than I even should have. So I think we're good. I guess the only point I would make is that, as I mentioned before, I think not necessarily that technology is going to save us, but I think that we should all be confident that we've got the smarts and the wherewithal to be able to create the tools and the ability to deal with our new reality. And the new reality is what we're seeing today. And there's lots of companies out there that are going to help us deal long term in terms of carbon removal and all of these other kind of things. But right now, where our focus is, where my focus is, on helping people today with the technologies that we have in-house. And that's why I'm excited about Meteomatics, because I've been in this space for a long time, and this is a super exciting company. And for the U.S., it's the best and most important weather company that nobody's ever heard of. And I'm going to be changing that here over the next year or so.
Great. Paul, if people would like to know more, to your point, about this, any of the topics we discussed on the podcast today, or yourself, where would you have me direct them?
Well, I would say Meteomatics.com would be the first place to go. And then you can get to me through there if you've got any specific questions. Yeah, we've just established, just by the way, our U.S. office here, and it's in Pennsylvania actually, and we're staffing up. So if you've got anybody if anybody is listening to this that's interested in sort of joining our crusade, you can reach me right through Meteomatics.com.
Perfect. Paul, it's been fascinating. Thanks a million for coming on the podcast today.
Thanks, Tom. Great to see you again.